Alright class, so this is for part 2 for organic chemistry. We're going to keep talking about alkane. We started talking about alkane. We said alkane are hydrocarbons that only have carbon and hydrogen, and they only have carbon-carbon single bonds and are used for fuel. And we went over some of the naming for alkane, and then we also went over cycloalkane. That's alkanes in a ring. Now what we're going to talk right now, we're going to talk about substituent. It sounds very fancy, but it's not. What substituent means, it means branch, basically. It basically means branch. So, you know how we said that you can have alkane, straight chain alkane. Now, sometimes when you have an alkane chain, the other thing you can have, when you have a hydrocarbon chain, you can have branches coming out of it. Okay? So the way to look at this, so I would say this is the backbone. Okay? This is the backbone. And then these are the branches that come out of it. Just think about if you have a tree, the tree has a bark, and then you have branches that are coming out of it. Okay? So when we have all these alkane chain, we have all this hydrocarbon chain, they could have branches coming out of them. So far, so good. All right. Now, I want to go over how you would name these branches. And again, you want to be fancy, you call them substituent. So I want to put up a table. And substituent and the name of the substituent. Let's go over it. So, again, you can have a CH3 to be a branch on your backbone. Okay? Again, one more time. So here I have a hydrocarbon chain. Here's my backbone, and I can have branches coming out of it. I can have a CH3 coming out of my backbone. If that's the case, what I call it methyl. Now, you already knew that meth means one carbon, right? And this is one carbon, so it has the meth prefix. Now, YL, that's for substituent. So it's methyl. I know one carbon is a branch on the backbone. Now the next one, let's say if I have a CH3, CH2 coming out of a backbone. So I have my hydrocarbon chain and I have a branch that has 2 carbon in it. Now you already know that if you have 2 carbon, then what are you? You are an eth, right? Now because this is a branch, then you call it ethyl, right? You call it ethyl. Again, is eth because you have 2 carbon, and then the YL is just for the substituent. So far, so good. Okay. Now, let's say I have a branch that has a CH3, CH2, CH2 is coming out of the backbone. What do you think you call it? Again, remember, 1, 2, 3, that's 3 carbon chain, right? 3 is prop, so it would be propyl, because 3 means prop, and a YL means you are a substituent. You're a branch. Are we good so far? Okay. Now, another one. This is actually kind of cool. I have a CH3, CH attached to a CH3. That is my branch. Now, this one is really cool because you probably have heard of this. We call this isopropyl. Where have you heard of isopropyl? Isopropyl alcohol, that's rubbing alcohol, right? So this would be the structure of rubbing alcohol, part of the structure of rubbing alcohol. Okay, so this is the branch that is coming out of the backbone. All right, now you can also have halogen as substituent. So you can also have halogen as a substituent. So what I could have a fluorine coming out. I could have a Cl, a chlorine coming out, okay? Now, if I have a fluorine coming out, if I have a, again, you can have halogen as substituent. If I have a fluorine, what I call it fluoro. So there's no YL. If I have a chlorine, I call it chloro. Other halogen, yes, I can have a Br being as a substituent. I could have an iodine to be a substituent. So I would call it a bromo, and I would call it an iodo. So what's going on over here? What's going on over here is that these are halogens as substituents. So just bromo, iodo, fluoro, chloro. So far so good? Okay, so yeah, these are substituents, these are the naming. Now, I want to make sure you really understand this concept of substituents, okay? So I want to come back here and I'm going to put an example up here because I really want you to understand the idea. If you look at this organic compound that I drew, it looks fancy, but you know how to read these now. Okay, there is a backbone. There is a main chain. Think about a bark of the tree. A tree has a bark and it has branches coming out of it. So what is my main chain? What do you think? This is my main chain. This is my hydrocarbon backbone. This is the bark of my tree. Now, which one are the substituent? The substituent are the branches that are hanging out of it. I have this as a substituent and I have this as a substituent, okay? So if you had to name the substituent, how would you name the substituent? Again, here's my backbone, here's my main chain, okay? And then I have branches coming out of it. Now if you had to name the branches as a substituent, how would you name it? So this one, I would call it a bromo, right? And then here, what would I call this one? 1, 2. This has 2 carbon attached to it, right? This has 2 carbon attached to it. So I would call it an ethyl. I would call it an ethyl because 1, 2 carbon. This is attached to the backbone. This is attached to the backbone. Okay, so I would call it an ethyl. Again, because if I have 2 carbons attached to the backbone, ethyl, bromine, I call it bromo. So these are the ones attached to the backbone. So far so good? Okay. Alright, now we're going to talk about alkanes with substituent a little more. Let's see, I have C5H12. Again, this is an alkane, right? It's an alkane because 5 times 2 plus 2 would be 12, so it has 12 hydrogen. This is an alkane. Can you draw, and this is pentane. Can you draw this out for me? Can you draw this out for me? Is this it? Yeah, because I have 1, 2, 3, 4, 5. 5 carbon, and then we don't usually draw the hydrogen. If you want, you can draw it. Now here's the question for you. If I give you 5 carbon atoms, you can put it together more than just one way. If I give you 5 pieces of Lego, how many ways can you put that together? Not just one. If you ever play with the Legos growing up, there's many different ways you can put the Lego pieces together. This is the same idea. If you have 5 carbon atoms and 12 hydrogen, this is a more straightforward way to put it together, but this is not the only way we put it together. We can also put it together that it would have substituent. So what do I mean by that? How about this? How about I do 1, 2, 3, 4 backbone, okay? I need a backbone that has 1, 2, 3, 4, okay? I need 1 more carbon, and then I'm going to put a branch over here, and that would be my 5, okay? Would that work? Would that work? Do me a favor. So we know that if we count, there is 1, 2, 3, 4, 5 carbon. Can you put the hydrogens down? let's put the hydrogen down and actually draw him out. This carbon has 3 hydrogen because it has 1 bond. This carbon has 2 bonds, so he needs 2 more. So he's going to have 2 hydrogen. This carbon over here has 1 bond. How many more does it need? 3 more, because carbon makes 4 bonds. I need you to remember that. This one over here has 1 bond. It would make 3 more to be 4. Okay. Now this one is 1, 2, 3. 1, 2, 3 bonds. So it would need just 1 more. So 1 more hydrogen. Let me draw it better way. Would be drawing it here. So far so good? Okay. Again, that's because now it has 1, 2, 3, 4. Because carbon needs 4 bonds. Carbon needs 4 bonds. Now count the hydrogen for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We just counted the hydrogen and we had 12 hydrogen. Isn't that interesting? So if I have 5 carbon atoms and 12 hydrogen, you can put it together more than one way. The most straightforward way is just in a row, right? Just attach the carbon in a row. But you could also have branches. Okay, how about this way? Can I draw it this way? Let's see, I have a branch. I have a backbone that has 1, 2, 3. And then I add 2 branches. Would this work? Let's see. How many carbon atoms do I have? 1, 2, 3, 4, 5. So I have 5 carbon atoms. Okay, let's draw the hydrogen together one more time. This carbon has only 1 bond, it needs 3 more. This carbon has only 1 bond, it needs 3 more. So I go 1, 2, 3, 1, 2, 3. Okay, this one again, it has 1 bond, needs 3 more. 1, 2, 3. This one also the same way. How about this carbon over here? 1, 2, 3, 4. It already has 4 bonds, so it does not need any hydrogen. No hydrogen. Ooh, let's count the hydrogen. What do you think? It's going to add up to 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It sure did. Okay, so that's another way I can put together 5 carbon and 12 hydrogen. That's interesting, right? That's interesting. Okay, now what do we call this? There's a name for this. What do we call these? We call these structural isomers. Structural isomers. Or another name for it is constitutional. Constitutional isomer. We call it structural isomer, or another name for it, we call it constitutional isomer. What are they? Here's what they are. They have the same formula. In this case, they all have C5H12, but different connectivity. Just think about, if you have 5 pieces of Lego, there's many different ways you can put it together. There's not just one way. So here you have 5 carbon atoms and 12 hydrogen. There are many ways you can put it together. And C5H12 has 3 constitutional isomers. Okay, let's do a practice with this. These are fun, aren't they? C6H12. C6H12, it has 5 structural isomers. Now this is a really good practice. Pause me and try to draw it out. Remember, the easiest way, you just put all 6 next to each other. Then put 5 next to each other and then have a branch. Then put 4 next to each other and then have a branch. And then go on. So there are 5 structural isomers. So let's do this. So the easiest way, of course, is for me to put all 6 together. So 1, 2, 3, 4, 5, 6. That's the easiest way. 1, 2, 3, 4, 5, 6. 6 carbon atoms in a row. That is my number 1. Okay. Now what I'm going to do, probably the easiest way to me, is 1, 2, 3, 4, 1, 2, 3, 4, 5, and then make one branch over here. Okay, that's what I did. Hopefully you did that too. Now the next one I'm going to do, I want to do again 1, 2, 3, 4, 5. Always count your carbon. I lose carbon all the time. And what if I put the branch over here? What do you think of these two? These two are identical. Because if you flip this one, it will just, you can superimpose it on that one. If you flip it, it will be the same as this one. And you don't notice right now, but you will notice later. They have the same name. So when I'm not sure if something is exactly the same, so these two are identical or no, I usually name them. And if they have the same name, then I know that they are going to be exactly the same. So keep that in mind once we learn how to name compounds with substituent. If they have the same name, they're going to be the same compound. Don't bother. Alright, so now how about this? I still can go 5. I still can put 1, 2, 3, 4, 5. And then, what if I put a branch right here? Yeah, that would be 1, right? Again, count the carbon. So I have 1, 2, 3, 4, 5, 6 carbon. More than welcome to count the hydrogen. You will also get 14 hydrogen. Right? Because again, as long as you have 6 hydrogen, 6 carbon, you are going to have 14 hydrogen with only single bonds. Okay, so I have 3 of them. I need 2 more to go. 2 more to go. I think I'm done with having 5 as a backbone. What if I have 4 as a backbone now? 1, 2, 3, 4. Okay, and then have a substituent, and then have a substituent. So 1, 2, 3, 4, 5, 6. Again, these are, you're probably going to go, whoa, what is this? This is the first time you've seen this. You're going to get used to them. You're going to get used to them. Okay. Now, there was one more I could have done with 5 that I didn't do. And I'm not happy with myself, but that's okay. There was one more with 5 I could have done. There's nothing else with 4 that I can do. 1, 2, 3. No, 5 I couldn't do anymore. There's one more with 4 that I can do. 1, 2, 3, 4. And then I can put 2 substituents over here. Yeah, huh? 1, 2, 3, 4, 5, 6. What do you think of that? Okay, that's good. That's good. Now, some of you guys may go, well, hold on. Can I do this? Can I go 1, 2, 3, 4 and then put 2 over here? You could do that, but it would be exactly the same as this one, right? It would be exactly the same as this one. 1, 2, 3, 4. You have on the second carbon, you have 2. You have on the second carbon, you have 2 of these. So it would pretty much be, these two would be the same one. Okay, now this is crazy, I know that, and the best way to know that these are identical, if you can't see it right away, is to name them. When you name them, you will see that they're gonna be exactly the same name, so then they're gonna be the same. Because again, these are moving around. I can flip this, right? If I flip this, I would get that. I can flip it, I can rotate it. If I flip this and I rotate it, I will get this. Flip, rotate, I will get that. So they're exactly identical. Alright, so, but the point that I want you to know right now, that all of these are C6H14, they all have the same formula, but they have different connectivity. And that is possible, because there's many different ways you can put 6 carbon and 14 hydrogen together. And if you don't trust me that they all have 14 hydrogen, put the hydrogens in and count them, and you will see that they all have 14 hydrogen, right? We can do one together just for fun, so you trust me. Let's go here. This one has 1, this carbon has 1 bond, it would need 3 more hydrogen. This carbon here has 2 bonds, so it needs 2 more. This one here has 3, it has 1 bond, so it would need 3 more. This one has 1 bond, so it would need 3 more. This one has again 1 bond, and it would need 3 more. And then this one would need no hydrogen because 1, 2, 3, 4. Because you gotta remember, carbon is how many bonds? 4. Ready to count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my god. 13, 14. Yes, for a second I was like, no. Let's count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, it matches up, right? I have 6 carbon and 14 hydrogen. This deserves a smiley face. Alright, so these are the structural isomers. What I want you to get out of it is that there's not just a straight chain that we can connect the carbon. There are different ways we can connect the carbons together. Alright, so let's go back to what we started. So again, just remember, these are all alkane because alkane have nothing but single carbon single bond, and it's not just a straight chain you can have. You can also have substituent, and this is how you would name the substituent. Now, what are we going to do next time? Next time we're going to put it all together. We're going to put it all together and be able to name all of these compounds. That will be next time. I will talk to you guys next time.